All right, Algebra 1B students, welcome to part 2 of lesson 9.1 on quadratic graphs and parabolas. Just a couple things to do in this video. We will compare the widths of parabolas to see how wide or narrow they should be, and we will look at graphing a little bit more complicated parabolas. But we're going to start with determining the width of a parabola. By width, I mean how wide is it between the two arms, you could say, of the parabola. So an example of a wide parabola would look like that. A very narrow parabola, something more like this. Wide versus narrow. That's what we're going to investigate. We're on the top of page 548. So you have your books, you can turn there with me. And you'll see right at the top, it says, the coefficient of the x squared term in a quadratic function affects the width of a parabola as well as the direction in which it opens. Now we looked, in our last video, we looked at the opening up or opening down, right? Whether that number in front of our x squared is positive or negative. Today we're going to look at what that number does to the width of the parabola, making it wider or more narrow. When you have two graphs, both of them being quadratic, and you want to compare the two widths, the smaller number in front of your x squared, meaning closer to 0, so absolute value of that number, smaller number meaning closer to 0, the number that's closer to 0 will have a wider graph. So it's a little bit counterintuitive, you could say. A smaller number means a wider graph. So for example, y equals 3x squared is going to be wider than y equals 5x squared. The same is true of negative 3x squared and negative 5x squared. So we always look at the absolute value of these numbers. So we just care about the 3 and the 5, not the negative side. Right? So you'll see problems like this next one in your practice problem set tomorrow. Using these graphs below, what is the order from widest to narrowest of the graphs of the quadratic functions f of x, which really just means y, equals negative 4x squared, f of x equals 1/4 x squared, and f of x equals x squared. The first thing I notice, real quick, is that this last one does not have a number in front of the x squared, so I'm going to put a 1 there. Because remember, when we don't see a number, we assume that that's a 1. So if I just look at the numbers that are in front of my x squared, I have a negative 4, I have a 1/4, and I have a 1. So I need to list those in order from closest to 0 to farthest away from 0. Okay, so remember, we make everything positive. Just make it positive. So this is a 4. This is a 0.25 or a 1/4, and that's a 1. I believe the furthest away from 0 is here, my negative 4. So I think that's going to be my narrowest. This is narrowest. First, that's my narrowest. So my widest, obviously, then will be the 1/4. That's the closest number to 0. It's a 0.25 closer than this 1. So my order really from widest to narrowest is that's first. That's the widest because it's closest to 0. That's second. This one is third because it's farthest away from 0. And as we can see, that's actually true. Right? My widest parabola is here. That's my 1/4. Second widest is here. That's my 1. And my narrowest, my skinniest one is right there. That's my negative 4. Okay. Now, I would like you to try that as well. By graphing these three functions, or maybe not necessarily graphing them, but telling me what is the order from widest to narrowest of these three graphs. I have a negative x squared, which really is a negative 1x squared. I have a 3x squared, and I have a negative 1/3 x squared. I want you to tell me which one of those is the widest, which is the narrowest, and which is in between. So pause the video, order these three functions for me, and then come back and I'll show you the correct order. All right, our order here should be widest is f of x equals negative 1/3 x squared. Second would be f of x equals negative x squared or negative 1x squared. And our widest is f of x equals 3x squared. All right? Okay. Now, one final thing we need to look at for today, and that is moving a quadratic graph up and down along the y-axis. Okay. Yesterday, we looked at equations in the form y equals some number times x squared. Right? And we noticed that all of their vertices, they always start at 0, 0. And we're just going to transform those, which means move them up or down along the y-axis, by changing our form to be this one. So I want you to notice that the difference here is that I'm adding a number onto the end of my ax squared. So an example of this could be y equals 2x squared plus 4. That would be an example. Where my a value is 2, my c value is 4. The value of c, this number at the end that I'm adding on, moves the graph up or down, raises or lowers it. So, if we look at this first problem, just as a quick check of that rule, how is the graph of y equals 2x squared plus 3 different from the graph of y equals 2x? Well, when we see a positive number, when we see a plus number right here, that means we've gone up. Okay? Plus means up. Please put this in your notes. Plus means up. Minus means down. Plus means up. Minus means down. So what have I done to the graph of y equals 2x squared? I have added on 3. Since it's a plus, I went up, and it's 3 units. So I went 3 units up. It has shifted 3 units up because I added 3 onto my 2x squared. Now, I would like you to try these two graphs. I want you to graph both of these. I want you to make 2 graphs on the same grid, really, on the same piece of graph paper, and relate the 2 graphs. So make a table of values, x and y, for this equation. Make a table of values, x and y, for this equation. And graph those on that grid there, and then tell me how they are related. Pause the video, try that, take a few minutes, and come back, and I will show you what that should look like. Okay, my regular x squared graph, just to throw a few points into my table of values here, 0 means 0 in the y, 1 in the x means 1 in the y, 2 in the x means 4 in the y. So that one starts here, goes 1, 1, 2, 1, 2, 3, 4, and then I'll just reflect across and reflect across. Okay, there's my first graph, my y equals x squared. That's in black. I will do this one in red. Y equals x squared minus 3. Now, if I put 0 in for x now, my y value is negative 3. If I put 1 in for x now, my y value is negative 2. If I put 2 in for x, my y value is 1. So my vertex, I believe, is at 0, negative 3. 1, 2, 3. I have a point here, I have a point here, and I will reflect those across here and here. And there's that graph. And so what have I done to y equals x squared to get here? Well, I minus 3, which means moved down 3 units. Okay? If you did not get moved down 3 units for either of those two graphs, please make a note to ask me that in class tomorrow. Otherwise, you should be prepared for your practice problem set, comparing widths of two parabolas and graphing with a slide up or down along the y-axis. That's all I have for you tonight. Have a wonderful night.